Um, my name's Rajni Hatti, and I work for MaxMind, which is a company based in Boston, Massachusetts. And we create tools for online fraud detection and IP geolocation. And so today I'm going to be talking to you a little bit about ethical hacking for testers. And the inspiration for this talk just came kind of through my own process of learning more about security testing years ago when I kind of just got interested in the topic, and I didn't really, and I knew that there was people that are specialists that do security testing, but I was just interested in learning more about how, just as a tester myself, I could contribute more to just creating secure applications. And this idea of ethical hacking kind of really resonated with me because it's kind of taking that idea of hacking, which is something that's malicious, and turning it on its head and turning it into something positive that we can use as testers to just make better applications. So the first thing that I want to talk about is just why do we even need to do this? Why is this important? Because most companies have their own security testing team, especially larger companies. They'll have security analysts, penetration testers, and all those things. And why is this important for us? So one of the reasons, and probably the biggest reason, is that one of the skills that we as testers have that really make us unique on the software team is that we tend to have a really big picture view of the application. So we will be, because we have to test different components of the system, we don't generally know end to end how it works. And we know it from a technical perspective. And we also know it from a user perspective, in that we're kind of the first users of the application, and we are mimicking that experience for the users. And so that advantage that we have, that knowledge that we have, actually becomes a really big advantage when it comes to ethical hacking. And I'm going to talk more about how that is a little later, but that's one of the reasons that it's really worth it for us to learn this ethical hacking mindset. Next, we're typically involved really early in the software development process. So looking at that graphic on the left, we start any project in the define phase, and then we go on to design, develop, deploy, maintain. And as testers, we're typically involved in, if not in the define phase, then definitely in the design phase, and for sure very early in the development phase. And so a lot of times we would be involved even earlier than a security engineer or a penetration tester. And so that also gives us an advantage as well, because we can find, if we're thinking in this ethical hacking mindset, we can actually find these bugs and these vulnerabilities earlier in the process. And anything we can find earlier, whether it be a security bug or just a regular bug, is going to save the project and the company, going to save time and going to save money. So the earlier we can find these problems, the less of a domino effect it has on the entire system. So that's the other reason that we are really kind of uniquely skilled at this ethical hacking idea. And then lastly, security is a process. It's not a product. So it's not something that we just say, okay, we reached at this endpoint and we're secure and we don't have to think about this anymore. It's something that, because secure software is constantly evolving, we also have to evolve with that product as well, and constantly thinking about how to make it more secure. And it's not just one person, like a pen tester or a security engineer, that would be the person that's in charge of making a secure application. We all can have a hand in looking for vulnerabilities. And so it's important to think in that mindset that we're all contributing to this aspect of secure coding. So next, I'm going to dig a little bit deeper into this graphic that I was talking about, which is the software development lifecycle, and talking about using these concepts when, at the various stages of the project, can we as testers be this, have this ethical hacking mindset. So projects typically start in the define phase, and then they go on to the design phase. And then in the design phase is when more people in the company start getting involved in trying to figure out how to create this application. And a really useful tool at that point is called threat modeling. And this is going to involve just not QA testers, but it'll also involve developers. It'll definitely involve people from business side, thinking about how customers will actually use the application. And before any code's even written, those people can kind of come together and start thinking about how the application works and start thinking about what are the what might be typical vulnerabilities in this application. So for example, if you have an application that has a login, then that's definitely an area that can be exploited by a hacker, where they could try to do some type of credential stuffing or that sort of malicious entry into the system. And so right away, before we've even written any code, we're kind of identifying the areas that we know are going to be like kind of vulnerable spots. And we as QA are really we are very well suited for that kind of discussion, because when we write test plans and we write test scenarios, we're already kind of doing that. We're already thinking about how the user would flow through this application and how they would use it. And so, and we also know that somewhat of the technical aspects of the system. And so between having both of that combination, we can really contribute a lot into threat modeling if that's something that the project team decides to do during the life cycle of the project. And then after the design phase, we go into the develop phase. And the develop phase, of course, is the real bread and butter of what we do as QA, QA people. And so at this point, we're going to think about doing some manual testing. We're going to start trying to decide what we want to automate. And I'm going to talk more about that in later slides. But there's a process that we can kind of go through to determine how automated testing can best suit our needs for this particular project. And as a QA person, if you're involved in code reviews, that's another great way to contribute to this ethical hacking mindset, where if you kind of already have an idea of the ways in which hackers can try to enter into applications, then you can be thinking of that as you're doing code reviews as well, and kind of having that ethical hacking hat on during the code review process as well. Then we go into the deploy phase, where we're actually ready to move this application to production. This is where towards the end of the develop phase and during the deploy phase is when we get more involvement through, say, penetration testers or security analysts that might want to check and make sure that all the things that they expect to be in place for a secure application are there. So this is a great point at which we can start collaborating, and definitely even in the develop phase, really start collaborating with the security experts if you have those in your company, and start kind of just really just talking about the areas that you've already found that are kind of potentially vulnerable parts of the system. And there's definitely room for collaboration there of just understanding for them to help them understand what you have found so far, what you've uncovered, and then kind of have that back and forth is really useful from what I found, being able to help the security testers do what they do. And then, of course, we have deployment testing. So this is a way that we can also contribute to security testing, because a lot of times what happens is that our testing environment is as close as possible to a production environment, but it's not exact. And that's quite typical in most companies. And so there are some aspects of especially infrastructure or the overall way the application, the hardware is set up, that's going to be a little different in production. And so this is where we can contribute if there are already deployment testing tests that you already run, also contributing there in terms of security testing. Are there any potential areas where things that we couldn't test in our test environment could be exploited in the production environment because they're just a little bit different? So that's just a conversation, again, to have with the system administrators and other people in the company that know more about the infrastructure of the way the production system is built. And again, just kind of contributing the information that we have about what we know of the application can be really useful at that point. And then the last phase is the maintenance phase, where now we're already in production and now we're just making enhancements or adding features, and we need to do regression testing. And this is a great point at which we can do more automated testing. And when we do our automated testing and we start thinking about our regression testing, we would definitely want to be wearing that ethical hacking hat there too, and thinking about maybe there's some security tests that would be really useful at that point in our regression testing. And that would be a place that we would want to add that into our continuous integration. Okay, so now I've talked a little bit about how we're going to contribute at each stage, and then now I'm going to actually dig into what does this actually mean? Like, what are some things that's the specific things that we actually want to look for? And I thought that the best, easiest way to do that is actually go through an example project that I worked on, and how I tested it and kind of the thought process that I went through in figuring out what to test from a security perspective. So this is just a really simple data flow diagram that kind of talks about this particular application. The one in yellow, the DICOM application, is what we were actually testing. And DICOM is just it's a file format that's used in radiology. And so what would happen in this case is I have on the left, the dotted line shows, it kind of depicts like an outpatient center where you would go get something like an MRI. And so once you get that MRI, the machine has probably 100 to 200 or even more files that are associated with that scan. And DICOM is there's a DICOM protocol of how those files need to be transferred from place to place and how they need to be kept together, because you might have, hundreds of files associated with this one patient. So you need a way to a protocol to understand what the order they're supposed to be in and how they are to be transferred. And so this application basically handled all of that. So it took the actual files from the machine and it did a DICOM push, it's called, and it is able to push it to a hospital server where the doctors can actually pull it up and actually look at it. So the images are transferred using this application, and then the doctor can use what's called a DICOM viewer to actually pull up the scan and look at the patient's MRI. So the application here simply just takes images and packets them together and sends them off to another place. And so we configure the application to be able to send to certain servers. And so that's kind of the idea behind this application. It's fairly simple. So from there, as a tester, the first thing, of course, I start thinking about test plan and how do I want to plan out my testing. So I came up with this this way of kind of thinking through different security vulnerabilities and where I want to focus my testing. Because the most important thing, I think, as a tester is knowing that I might not be able to test every single thing perfectly when it comes to security testing, because that is typically why you do have a pen tester or you do have a security engineer who's really an expert at this. But there's a lot of things that we still can do to start contributing very early in the process, in kind of identifying even just where the gaps are and where we might need either add more tests, or maybe we need to, think about how we are designing something. And this also I found was really, really useful in not only me figuring out what tests I need, but also in just starting the conversations within our development team and even outside the development team with other business people in the company, of just kind of starting to think through very specifically, like, what are things that can happen in this application that could be a security risk. And so ultimately, this is really kind of like a risk analysis. And I'm going to talk a little bit about how I actually went through and thought about the different types of risk. And as you can see, red is considered high risk, orange medium, and yellow low. And so now I'm going to talk a little bit about how I actually came up with the coloring system of what I decided to where I decided to focus my testing. So across the top, I have the OWASP top 10. If you've not heard of OWASP, they're an international organization that comes up with these, kind of does some of the work for us in telling us what are very typical ways in which systems are breached. And this is updated yearly. At the bottom right, I have a link to the actual website that you can look at to get more information on all these. I'm not going to go into detail on every single one. We're just going to focus on a couple of them for this presentation. But if you're interested in this topic, that's a great site to start understanding more about this topic. So across the top, I went ahead and just picked out the things that OWASP has already told us are very common security vulnerabilities. And now I want to figure out, okay, in my application, which of these things actually apply to what I'm actually going to be testing. So on the left side, I have my use cases. And this is very much like what we already do when we start writing test scenarios. We're going to start thinking about what are the different, the workflows that I need to test in this application. And so I picked out 4 things that I knew were just very basic things that I knew this application had to do. And so we're going to log in. There's a way to ping a connection. So just as I was showing in the diagram, how you send the application needs to be able to send files from the outpatient center to the hospital. So we need to be able to have a way to actually connect to that other servers. And there's a special thing called a DICOM ping, which is more complex than just a regular ping. So my application needs to be able to do that. And then I need to be able to send these DICOM files. And then potentially I might even need to receive files as well, because sometimes there might be files at the hospital that need to come back to the outpatient center. So I want to make sure that my application can do that. And then now I'm going to go through just across one row and just kind of explain how I came up with this risk analysis. So let's just take login, for example. And so anytime that I'm thinking through risk, I'm thinking about 2 factors. I'm thinking about the risk of failure, and I'm thinking about the risk of impact. So the risk of failure is simply just how likely is this to happen? And so for the case of logging in, let's take the example of identification and auth failures, which is the 7th column over. And I marked that as orange. So how did I come up with that? So first, I'm looking at the risk of failure. So how likely is it that someone would try to, someone who wasn't supposed to be logging in the system would be logging into the system? And there's some sort of identification failure. Well, this particular application, it's a desktop application. It's sitting at an outpatient center on a computer in an area where typically there aren't a ton of people. It's probably going to be mostly the administrators of the outpatient center. It's not, since it's a desktop application, it's not a web application, so it's not something that everyone in the world can get to. It's very much localized to this desktop. So in that case, based on all these factors, the risk of failure might be a little bit less, because the chance of someone who isn't supposed to be getting access to that application might not have a very easy time getting to it. However, the risk of impact, so if someone actually did figure out a way to get to this application and log in, unauthorized login and get in, the impact could be very severe, because they could try to send files to the hospital server that either had malicious data in them, corrupt files, and that could potentially even bring the entire server down at the hospital, and this would affect every patient at this hospital. So the risk of impact is very large and pretty bad if it were to happen. So that's how I landed on orange, because I said that even though the risk of failure isn't too bad, we've got a very high risk of impact. So that's going to put us more in like a medium risk area. If something had a very high risk of happening and also a very high risk of impact, then that would definitely be a red X. So using that thought process, I kind of go through each one of these, and again, using the OWASP documentation just to understand better what these various issues, vulnerabilities are. I kind of came up with a plan of, okay, these are the areas that I want to focus on in my testing. And a lot of times on some of these, I wouldn't really know, like security misconfiguration is really, that was hard for me to really know the details, because a lot of times that's either an SRE or like a sysadmin that knows better how the system's configured. So it kind of is just also a way to instigate these conversations that I think are useful for the company to have around security. So that kind of gives you an idea of how I use this to kind of think through and break down something that's very large into some smaller bite-sized pieces. So next, we talked a little bit about how to decide what to automate. So now that I've done my risk analysis, I have a really good idea of kind of the areas that I want to focus on. And this is a good time to just at least start thinking about what I might want to automate. For me personally, I usually like when I test an application, I usually like to just start doing it kind of more exploratory and manual first, kind of get a feel for where I think that the vulnerabilities are going to be. And then once I have done more manual testing, I kind of decide, okay, these areas really would make sense to automate because they're either time consuming or they need to be part of the regression testing. So in this case, there's two types for security testing, two basic types of tools. There's static tools and there's dynamic tools. So on the left side, the static tools are things where it's really more of a source code analysis where we make the source code available to the tool. And it goes through and it can find issues, like you can see at the bottom there, like numerical errors, input validation errors, and things like that. And a vulnerability scanner is a good example of that, which most people have worked with as testers. And then on the right side, I have dynamic application security testing. So these are more of a black box test where we just feed some input into the system. We don't know anything about the source code, and then we get something out of it, and we essentially try to crash the system and see if we can do that using certain types of input. So this is really great automated testing to do for things like interface request response, injection, which is just using malicious code or malicious SQL to actually put it into the system, whether it be like either in a user entry field or into a file or something where we actually can use hackers can use that as a way to enter into system and crash it. Or another area is authentication errors. So if you remember back on this slide, I did identify under the third column in injection, I didn't identify that as a high risk area for sending and receiving DICOM files because someone could try to inject something into the file and use that as a way, like as a Trojan horse, essentially, to get something malicious onto our servers. So since I identified injection as something that seemed like a very high risk area in this particular project, doing a dynamic tool, automated testing tool really made sense. And so an example of that is a fuzzer, which is basically something where you put all kinds of data, malicious data into a system and you see if you can crash it. And I'm going to explain more about how we did that in a couple slides, but this is kind of how I identified that would be a good thing to try in this particular case. So now we're going to talk a little bit about actual things that happened during the project and things that we found as testers that kind of was wearing that ethical hacking hat made it easier to find some of these things. So this was in the design phase. And this is where we were looking at the designer had just created some basic workflows of how we were gonna have the system work. And so basically what this said is you're going to enter the username and password. And if it's correct, you'll just continue the logon. And then if it's not correct, you're going to send various messages to the user just explaining what went wrong. So we found actually that in the designer just not knowing that much about the security aspects of the system had kind of inadvertently created a security flaw in the design. And as QA people looking over this, we were able to catch that. And what that was this part right here. So we want to give the user very little information about what's wrong, whether it be username or password, because a malicious hacker can use that information to then try more and more different combinations and getting closer to basically it gives them information, and we don't want to give them that information. We want to keep it very we want to give enough information but not too much, and this was giving too much information. So the correct design that we suggested was just doing this, where we're just going to say invalid username or password, and we don't really tell them which part of it's incorrect. And that was a better design, and that kept kind of close that loophole of that vulnerability. So this is one example of the fourth item in OWASP is insecure design. So that is one of the areas that is a typical pitfall for applications. And so we're able to look at that and pick that out. And the next, as we were going into the develop and testing phase, we actually were able to start using the application. And one of the pages in the application, like I mentioned before, we do a DICOM ping. So you set up these outbound connections of where the files should go. And one outpatient center could be used by many hospitals. So this could have quite a few different outbound connections of where we want to send these files. And there is, of course, we have to put the IP address of the hospital and then the hospital server, and then there's a port number and an AE title, which is just very specific to these DICOM applications. And we need to, whatever we enter here has to match the server, the way we configure it on the server side of the hospital. So one of the things here was that this, when we enter the port number and AE title, if someone were to get into this application that wasn't supposed to be there, they could set up a new outbound connection and they could just keep trying to guess port numbers and AE titles until it worked. They can use a computer to actually hack into another system using our system as a vehicle for that. And so when you, so here on this page where we're seeing the DICOM ping, we had there's three things that basically have to be true for this remote, this DICOM ping to work, and which is I kind of already talked about the port and the AE title. And so as we're looking at this, we're thinking, the concern is that if someone were not supposed to be in here, they could set up and essentially send things to a server they weren't supposed to. So what should we do about that? So this is this actually falls under identification failures in that last top 10. And here is where I think I already kind of said this, is the hacker can use a computer to test a wide range of entries. And so what do we want to do about this? So the best thing to do in this case is do some sort of rate limiting where we limit the number of pings that can happen in a certain amount of time. So for a hacker to go in there and try a whole bunch of different combinations would be very difficult if we say limit the number of pings to like 5 in an hour or something like that. And then also when that starts happening, let's say we end up getting more than that, we want to log that error somewhere and we want to send an alert to the admin so that they can make sure that this is actually something that's okay and not a real problem. So those would be things that rate limiting is a good way to mitigate the risk of identification failures. So we're able to make that suggestion during the development phase. And then next, I'm going to talk a little bit about the fuzzer that Wei was talking about. And this is further on in the development process where we're starting to get to looking at our automated testing. There's various fuzzers out there that you can use. A lot of them are open source, and I think we had just picked an open source one that we saw. And the basic idea behind what a fuzzer does is that it would take these valid files, in our case it was DICOM files, and those are called the seed corpus. And so we're just taking a very diverse set of valid inputs. So I think we just took patient data that we already had, anonymized it so that we weren't using any real patient data. And then we use that as valid input. And then you feed that to this fuzzer, and then which is called the, and so that you basically configure your fuzzer to take that valid input and put it into your application. And what the fuzzer does is this actually starts mutating those DICOM files. So these are called fuzz vectors. And there I've listed some of the typical things that a fuzzer will do. So we might take one of those files and just remove some of the file attributes that we know, that are needed, or malform some of the data, corrupt the files on purpose and see what happens when you do that. And also you can inject viruses into files. So trying that and seeing how the DICOM application reacts to that. So the fuzzer takes those mutated files and puts it into this DICOM application, and then we're hoping, in this case, we actually want it to crash it because that's going to find the security vulnerabilities that we wouldn't want to go to production. So we ran this through this fuzzer, and we found some interesting results. It did have a crashing workflow where when the DICOM image was injected with an executable file. So DICOM files, just the nature of these files, they have all these different meta tags, which contains all the information about the patient, the actual scan itself. There's technical information that's contained in this metadata. So there's a certain field in the metadata called a preamble header that you can write information to. And by injecting a malicious virus into that header, we're actually able to send that file to the test server that we were sending, which would have been a hospital type server, and it was able to crash the application. So it was a really great find, and the fix for that, which is what the developer suggested, was that in this case, we want to verify that that preamble header tag has only the information that we would expect. So we want to do some validation on that and make sure that it doesn't have things that we're not expecting. So in yellow at the bottom there, the resulting good workflow was that we verified that 128 bytes only start with 2 different things, and anything else would result in that file erroring out, or that all those files erroring out. And so we retested that, and that worked fine. And so we were able to use that automated approach in a way that was really useful. And that covers injection. And so that kind of gives you an idea of the thought process. I think every project's different. So it kind of came up with these 3 L's of ways which I think we all can kind of help contribute to this security process. And we kind of already have talked about this, but the first idea is just to listen. So listen, and the picture kind of shows you people collaborating, and that's part of listening, is collaborating and understanding other people's points of view of how the system is being used, how a user would use it, how a technical person might use it. You could have multiple different types of people using the application. So we want to understand all the different types of personas that are going to be using this. And that can really only happen from this type of collaboration where we're listening to other people, starting those conversations. And I think that that's a really important aspect of just contributing to secure applications. And the second thing is to just keep learning. This is just a landscape that changes very, very quickly. And there's always new ways to hack applications. And so we have to kind of stay abreast of just what is new in the field. I think we all are very busy at our jobs, and I am just like anybody else. And so I don't have time to necessarily spend hours on this at other times outside of work. So my approach to this is really just kind of incorporating it into what I already do. Part of why I even started learning about ethical hacking is because that just was one topic in security that really resonated with me, because it so much aligns with what I already do every day. And so as I started digging more into that topic, it kind of just became second nature for me to just think about those things as I'm doing my work anyway. And so I think that's kind of an important part of the learning process, is just to kind of read new things, go to presentations, and just absorb things that you might be able to incorporate into your daily life without necessarily having to do something extra outside of what we already have to do every day, which is, usually a lot. And then lastly, although it seems a little obvious, is looking. And looking is just actually looking for these things. And I think if you're listening and you're learning, you're kind of supporting your ability to look for things. And so as you do testing, code reviews, and all those things. Just keeping this ethical hacking hat on really helps you look for these little things that you might miss, or even might get missed until it's too late where it's already in production, or maybe it gets caught by the penetration tester. But it would be nice if we can catch them as early as possible in the life cycle. So just looking for things, it's just seems simple, but it's a really way that our skill set really can help out in creating better applications. And that's it. Thank you very much for your time.
Awesome, well done. Thank you for presenting that. We will move into some question and answer mode here. So if you have a question, you can feel free to unmute yourself. And if you don't feel comfortable unmuting, then you could type it in the chat and we could read it off there and answer the question that way.
Yep, I'll go question, Rajni. Thank you for the talk. The way you described the project, it sounded like it was a kind of reasonably large scale project to sort of design and define and so on. Have you tried to apply the sort of ideas that you've had here on more iterative projects? Often you're trying to bash through, get your tickets finished, and where are you going to put the security testing when you're working at that kind of iterative scale?
Yeah, that's a really good point. I think and I think that in that case, like there are times when I don't even really need a test plan for certain things that I'm doing because they're just small, and you just kind of test them. You kind of do the test cases, and then you just test something, and then you just push it to production. I think in that case, it's important. I think I think in the beginning, I think when you're first learning about these concepts, it might be harder to apply it to these really small iterative things. But I think like now I'm at a point where it's more second nature. So it's easier to apply it to an iterative thing where you don't necessarily have time to do a whole risk analysis and all that stuff. It might be something that you are just doing more in the back of your mind because it's become more second nature. So I think the best way to get good at doing this in a more iterative approach is to just even if you just do a risk analysis, but a more modified version of what I showed you, without having to do like a whole table and all that, just even writing down some notes about, hey, what are just some really simple things ways in which this particular feature that I'm testing could be hacked. And then going from there and doing kind of like this modified version of just trying those tests out and then seeing what happens and then potentially adding that to your automated testing suite. So that's the way I would approach something like that.
Yeah, thanks. Have you tried maybe putting security into a definition of done? Could that approach work, or is that kind of imposing too heavy a load?
Yeah, I think that's a great idea. I think that, yeah, exactly. Definition of done is just, that's part of what says this is ready to production, because we've kind of just thought through this, even if it's limited, limited effort in putting our heads together about this. But I think that'd be a really great place for that.
I had a question on, so our company has talked about OWASP top 10 for a few years now. And what I've noticed is that sometimes the top 10 can change. So there are some other either newer attack vectors that come up as being more predominant, or even, I guess what I'm trying to say is when those OWASP top 10 change, do you have the ability to kind of go back into, do you see yourself going back into previous projects and saying, we didn't test for this new OWASP top 10, should we go back and double check that old application that we checked the original top 10, is it susceptible to these other, so do you have any experience with that and what that looked like?
Yeah, I think it's a good idea. I mean, my experiences, they haven't changed such a huge amount that it requires so much more regression testing. It's usually enough that you can just go back and check and kind of do a little, or even I think what we've done in the past is just add more regression tests that, that are kind of update our regression tests, security tests based on the new top 10, and do it that way. And then just do like some exploratory testing just to make sure that it's working the way it should. Yeah.
And then do you have like a recommended fuzzer that you've used that you liked?
Yeah, you know what? I should look up the one. I know there's different ones for different languages. This was written in .NET, and so I have to get back with you the name of it. I don't remember. But I know there's one for Go that I've used at work before called what is that one called? I'll have to look that one up for you too. But there's one that works for Go that we in my company right now we use a lot of Go. So there's that. And then there's one for Perl that I think works pretty well too, which I haven't tried. But if you just do an online search, there's a lot of open source stuff out there.
Yeah, that's fine. I can do that. I just wasn't sure if you had like one that you're like, this is amazing to use and easy, and here's like benefits I got out of it. I mean, and you showed us in your presentation, like it was very helpful. I just wondered what those tools kind of look like. So thanks.
Mhm.
And I don't have anything in the chat. Is there anybody else that has a question?
Yeah, I had a quick question, less around tools and more around like culture and issues that kind of come up as a result. Like one of the things I remember um, in the aspects of enterprise testing and getting people involved in security and even having a dedicated security team involved is that it's great to get more testers involved. But it was also a little bit of a tricky situation where the security team would not necessarily be able to provide a lot of information about vulnerabilities or anything like that. And then another thing that popped up is that once someone on the testing or QA team or engineering team found vulnerabilities, how do you start to now protect yourself internally from, a threat that could be, from within your organization? So was just kind of curious if you had any thoughts on that and how you've seen that handled in your experience.
Yeah, that's really interesting. I think, yeah, so much of that depends on the company culture, because I think if you already have a culture of having some of those that discord there, it's going to show up in a lot of different places, and security is just one more place where it shows up. I think the places where I have mostly worked have been kind of promoting a safe space to bring these kind of a no blame culture. And I think that's really, really, really important for this kind of, just in general, it's important, but for security, it's even more important because people might feel afraid to even bring something up because they don't know if they're going to get in trouble, or if they, like they are going to somehow get, pinpointed for this. And so I know, where I work right now, we make an effort to say it's a no blame culture. And I think people at the top of the company really need to make that clear, that it's a no blame culture, that, like they say, if you see something, say something. And that's really, really, really important in order to be able to do this in a way that is where it is a process and not a product. It is really important to have that. So that's something that everybody, especially people at the top of the company, have to really commit to.
I'll just add one more, if that's okay, Dwayne. Yeah, more of a thought really on your software development lifecycle slide at the beginning. You had kind of regression testing once you're in production. One of the things that I found useful at my current company is using the observability tool. We have Honeycomb and mining the production data, looking for patterns, particularly, for example, in one instance, a particular user logging in like many thousands of times, but predominantly more than other users, was really valuable, looking for potential security issues. That particular user was trying to scrape some of our data. So I think maybe you may already be doing it, but it might be something perhaps to add on to the slide.
Oh, that's a good point. Yeah. And one of the things that comes under, I think one of the things in the OWASP 10 talks about logging and how important logging is, because that's normally how some of these things like credential stuffing and things are found, is that you're looking at this production data and seeing patterns for, there's someone trying to log in so many times, or something like that happens, and then alerting people to catch that early usually helps mitigate that So yeah, that's definitely a great idea.
And then to go along with like the culture question that Tariq had, and you were talking about how like it has to be bought in with like top management. I guess could you describe something that's helped the team at the basically if I'm assuming that most of the time you're going to get management to say, yeah, we really do care about security. We don't want to be one of those companies that gets put on like the front page of being hacked. So therefore, it's important. But how do you get some buy-in from what are some of the successful ways you've seen teams get buy-in on the lower level to say, yes, this is something we want to incorporate very easily into the process and keep on top of when they might be a little bit bombarded by, well, this new feature we want to get out and we want to go fast. And the tendency of more companies lately has been to release as much as possible. So could you just describe like one way that you found to get the culture started at the team level very easily?
Yeah, and I think part of, you know, what I emphasize in this presentation especially is like trying to find ways to incorporate into what you're already doing, because I think that's really important, not having to spend separate time doing this, because yeah, most of us don't have time and we don't want to slow down the project. So I think first just understanding, kind of internalizing some of the things that we might want to look for as an ethical hacker, and then from there just incorporating that into what you already do, because this isn't really taking the place of what a pen tester or a security engineer would do. We're just kind of keeping an eye out, using our skill set and what we're already good at, and just kind of adding the, you know, the cherry on top, I guess you could say, of just finding some of these things. And so I think that the best way to get buy-in that I've found is kind of like, even if I'm testing with somebody on my team and I notice something, and kind of collaborating with them and say, oh, look, you know, I had this one test scenario, I found this. And so then the next time they're thinking of, oh yeah, we found that this one that last time, and you know, I should look for that this time. And so I think just kind of in that way, just it's creating an iterative process for it, just like you're iterating on the software, and just kind of including it into that iterative process, I think is probably the easiest way.
All right, cool. So yeah, seems like it was just yesterday, but it was a while ago now, cast. So hey everyone, my name is Tariq King, and welcome to my session that I presented at CAST, towards better software, how testers can revolutionize AI and machine learning. And you know, people are tempted to think, oh, this title seems a little bit backwards. What do you mean? Normally we're talking about AI revolutionizing the world, but it's not a typo, it's not a mistake or error. The truth is that I think AI and machine learning will definitely revolutionize the way that we do things, but we have to enable that revolution. And so we always talk about, you know, man versus or woman versus machine. And this talk is kind of a little bit of those traces. And so we'll get into it, because I presented on the first day a tutorial all around using AI and machine learning to do testing and to do test automation, and talked about how AI and machine learning are really bridging a gap in terms of some of the things that we can automate. Does it mean that the bots are testing everything and that we don't need humans? No. But there are definitely some capabilities that we have now because of machine learning that we didn't have before. And you know, when I talked to teams, when I presented that day, communities across the globe, they always say that they're tired of the hype of machine learning and AI. There's a lot of marketing. A lot of the vendors are always pushing the fact that they have AI-driven platforms and this stuff. And folks tell me, I want the truth. I want the truth about AI. Please give me the truth. And you know, while I think that this is a noble and honorable thing, I also think that a lot of you can't really handle the truth, even though you say you want the truth. But I'm going to give you the truth anyway, as part of this presentation, and you know, as part of CAST 2021, it was a key part of it, because the truth is that there's still a few good men and women out there talking about AI and testing and software engineering very openly, and also would like to kind of stick to what is the reality of this technology. I look at its intersection with software engineering and testing very openly and honestly. But there's one thing that I had to just pause on, because while we're here to talk about these things, I felt like there's another kind of presentation that we needed to kind of follow up on, and I stopped and I just said, well, let's take a step back, because there's the truth, but then there's always perception, and the perception is that AI and machine learning are gonna eat software the way that software kind of ate the world. And the reality of that is quite different in my perspective, whereas that the truth is that software hasn't eaten the world. Bad software has eaten the world. And the world is actually paying like a revolutionary price for that bad software in the form of defects and issues and the overall total cost of quality when we look at it. We're paying a lot for the cost of poor quality instead of making quality really that investment. And so maybe, just maybe, there's some alternate reality out there where there's better software. And I think I dream about this thing on a nightly basis. A reality where AI and machine learning aren't really such a threat either, because they're being held at bay, allowing better software to survive and maybe even thrive in this world. And so we'll get back to that, because I did also promise you that I'll tell you the truth about AI. And the fundamental truth is that AI is here. And it's resulted in several breakthroughs, which are continuing to boom even as we speak right now in the 2020s. Machine learning is actually enabling us to solve problems that we couldn't solve before with computers. And I'm not talking just about the high profile AI type of, personal assistant, self-driving cars, the things that hit the media. But in our very own field of software testing, and as part of the tutorial at CAS, I showed how specifically for test automation, we're able to leverage autonomous agents, or these bots, and they can help us do things like automatically explore and generate tests and do visual testing and more. These traditional things that, when you think about testing a UI design, like we always think, well, there's no automation for that. But now AI can actually simulate a lot of the human judgment that can be necessary to determine, hey, is this a good design or a bad design? And that's pretty remarkable in itself. And so AI is here. And the other part of the truth that we should really highlight is that it doesn't require skilled programming. And there's a lot of myths out there about what is necessary. And AI and machine learning are sometimes presented as these very highly complex paradigms that we simply can't understand or learn how to program. And people always point to neural networks and how they're hard to explain and hard for us to understand. And a lot of that is true, but there's several machine learning models that are easier to explain and very much even align well with testing. But the truth is that you can get started first and foremost without even touching a single line of code, and that can get you actually pretty far with machine learning. There's several environments and popular environments that you can use. There's Weka, where you don't need to have any programming to get started, really. It's a graphical workbench for machine learning. There's BigML, which is a web service where you can upload your data, prepare it, and run algorithms on it. And then Orange is a completely a design tool, a modeling environment where you can do some of the same things, where you prepare your data, the algorithms, check the results. And there's several benefits to actually starting without code, right? Because if you think about the fundamental aspect of computer science, which is really around problem solving, you are sometimes tempted, once you're going through that process, to jump to the keyboard and start coding. And so by removing that need for a strong coding background actually means there's a lower barrier to entry to start developing systems using machine learning. And this is especially really good for those non-technical testers, folks who tend to shy away from programming. But more so, like, you start to be able to focus on experiments, right? The core problem solving that you're trying to do, you're trying to test some hypothesis or trying to get feedback on a particular problem. And so now you're really focusing on that path from problem to solution, rather than jumping to just coding a solution, which usually leads to bad software or poor quality in some form. So imagine that we're back to doing actual problem solving, right? This is the essence here. And even if there is programming, which there's a lot of the complexity that therein lies is hidden by a lot of the libraries, right? We talk about the Python programming language, and the libraries that are written in Python actually abstract away a lot of the machine learning algorithms and the complexity of that algorithm and machine learning in itself. Tools like libraries like scikit-learn give you several algorithms that allow you to process data out of the box and set up your data frames. And you don't need to know how to implement specific algorithms like k-means clustering from scratch. You just need to start to learn the context that you can apply this to, and then call the library to set it up and prepare your data and go from there. NumPy for numerical functions, pandas for data frames and libraries to manipulate the training data and the results. And the latest algorithms are actually available on platforms like R for statistics and machine learning, state-of-the-art algorithms. So, the coding aspect of it isn't really a big deal. And it's even getting, more ridiculous, right, in that sense, because there's a huge movement towards what is called automated machine learning, or AutoML. In other words, the machine learning problem is being turned on itself, where you're using machine learning algorithms to auto-tune models and other ML algorithms. And AutoML is basically replacing the function of the data science teams. And it's a very meta thing to think about, but you have the ability to do quite a bit. And on the first day in the workshop, we actually spent some time using Google's AutoML vision and taking a look at that and what the AI is actually able to interpret, just again from something as simple as calling a single API. And so you don't need all this technical experience and expertise to engage with that. All right. The other truth that I found is that machine learning actually bears a lot of similarities to software testing. And so for testers, this is actually quite exciting. The process of training a neural network is very, very similar to what we like to refer to as black box software testing. On the machine learning side with the neural network, you're preparing your training data and even test data, feeding it into this model, and the model is supposed to make predictions. And what you're doing at the end of the day is saying whether or not the predictions that the model made actually match the expectations that you as a human user or someone who's interacting with the system would actually expect. And that's testing, right? That is similar to treating your program like a black box, feeding it inputs and different preconditions, setting up those, and then checking the actual output and comparing it to the expectations. And so that's actually quite refreshing to see that there's a direct correlation with now what is on the left a programming model versus the right, which is typically a testing kind of environment. And the models themselves are actually quite similar. There's a few examples. In particular, I know when I started looking at decision tree learning, which is a machine learning mechanism that uses various conditions and the probabilities of those conditions to just model what are some expected outcomes or those predictions. And when I started looking at this, I was like, wow, I already know what this is. This is very similar to decision table testing in software testing, one of the first like black box techniques that I learned, which is also applicable at the code level to ensure how you're adequately testing conditional logic in the program. But similarly, you have these conditions that you have values assigned to, or these predicates that can be true or false, and then you have actions, which are your outcomes, right? And so that was cool, and there's a few more examples like that. And one key thing that is common across both is kind of this focus on data, right? So in machine learning, you have your training and your test set, and you might have a full data set and then split it so that you hold back some so that you can assess how well the machine is doing predictions. But testers, they deal with data all the time, right? Whether you're talking about data that you synthesize in the lab, or you're talking about production data, and you're always trying to do things to be able to manage that test data. And so it's a key thing to recognize that that skill set from a testing perspective also directly translates and actually shifts all the way left now, because machine learning is really a programming paradigm. And I found that it's not just similarities, but it's just a lot of complementary things. And so you can start to think about the skill set that testers bring to the table. You have something simple like classification in a machine learning model, and you're talking here about, hey, can I take these discrete values, cats and dogs, and can I, basically draw a line that partitions my data so that I can differentiate these two classes from each other. And that is a partitioning problem. And as you know, we have several partitioning problems and solutions in the testing world, particularly equivalence class partitioning or equivalence class testing is something that you learn early, because the testing problem is infinite. And how do you deal with that infinite input space? Well, you try to partition things out and look at the behavior of the program and whether or not that behavior is similar, so that you can then take a representative data point, test that data point, and consider that the whole partition is covered. And so testers are no strangers to this. We use equivalence class partitioning all the time to reduce the number of test cases that is required to cover the input space, because we know that we're going to run out of time during testing. And so that's definitely a complementary skill when you start to think about it. And when you look at any partitioning problem, there's always these boundaries that you draw these lines through or draw these lines around. And even thinking about how testers approach thinking about test data and test inputs in a partition, we actually need testers to help reduce some of the confusion, right? The bots can get confused between cats and dogs, for example. And how do you really start to make that something that is more proactive than reactive? Well, testers come up with these data points, right? What if you test something that really looks like a cat, but it's a dog? What happens then, right? How can we really test that boundary between those two things? There's many different dimensions of these complementary techniques as well. One that I find particularly interesting is that in the machine learning problem, you have this challenge of thinking about how are you going to get enough data samples to really represent and train this algorithm to simulate whatever function you care about. And of course, you need representative data. You might need a lot of data. And one of the techniques that's used is the idea of data augmentation, where you take a test data set and you take an individual point and you just apply these, maybe filters to it, right? So for example, this butterfly, maybe you apply these different photo filters to it, where you decolorize it or you enhance the edges, and now you get all these other data points that now can help to train the machine to be more robust at recognizing things that it hasn't seen before, because now you have all these different lighting conditions and things like that. And I thought that was very cool, and it reminded me so much of the fact that in software testing, when we're evaluating test sets, we have the idea of using mutation testing, where what are we doing there? We're taking an actual program or specification, and we're applying these transformations to it, these mutation operators. And then you get these mutant programs. And these mutant programs might be, seeded with bugs, or you change some operator, and you're running your test set to see if you have revealed those issues. And while that is a test evaluation mechanism, a lot of the work where you are thinking about these mutation operators and codifying these things is very useful and applicable to this idea of data augmentation. And so when I look at this intersection of AI and testing, where you have AI-driven test automation, you have the need to test AI systems, and then because these systems are very dynamic, there's this need to also think about how do you make testing an integral part of the software, and maybe design it with some testing capabilities as part of it. It makes me wonder if this is really an intersection of fields, or are these codependent fields? And for me, there's just no doubt when it comes to dependency that AI needs testing, right? There's a growing concern that is out there where we're starting to see these rising issues between these quality implications for AI and machine learning work streams, right? We talk about the fact that AI can be very dynamic. It can learn after it is released and so on and so forth. And just building it, we don't know exactly what it's doing, or we don't know how to explain how it came to a particular decision. And so as we continue to mature our quality practices in non-machine learning or traditional work streams, so to speak, we're going to continue to see this disparity between these two areas. And as I mentioned before, this idea of continuous machine learning really is going to require continuous testing or even self-testing to be a part of the system. And so this is where I definitely see the need to make sure that we have adequate testing, we have testers involved from early. We're thinking about all of these issues. Even we saw the security talk today, and I'll talk a little bit about that. But all of these things are factored into the continuous testing effort for machine learning. And then while AI definitely needs testing, I think testing needs AI just as much. We've, in my opinion, have settled a lot for substandard definitions of what something means to be automated. And we call these test scripts that we write manually and that break all the time and we have to be involved. We call that automation in the testing world. And it kind of really blows my mind that that we had settled for that. And now things are getting better, and this is nothing against these specific frameworks that are out there. These things provide value, and if you follow good practices, they work well. But for me personally, I always felt that there has to be something more than this when it comes to automation. Like we need to think about the actual testing that goes on, not as a result of applying inputs to a computer program, but all the creativity that goes into learning about the system, assessing its behavior, exploring it, then crafting test experiments, which is what they are, right? Your hypotheses and running those things. And so again, I think that where that kind of stuff is definitely a lot more formalized in the AI machine learning world, we need to get down to that and think about how we can build tools that actually support those functions, that automate the learning and automate the test case generation, and automate the analysis of the results in these things, right? And not think of this very limited type of automation that is really not very general. It's not reusable across applications and platforms, a lot of the things that machine learning and computer vision bring to the table. And it's very hard to maintain and expensive. So to me, it's a very exciting time to be in software testing. And this dependency actually creates a lot of opportunities. And that's great because, even from what you've seen already, you can start to think that there can be these crossover or this cross-pollination of techniques from the testing world to the AI machine learning world. And it was actually motivation for me to create a course for O'Reilly on just quality engineering and holistically thinking about quality engineering for AI and machine learning systems, and finding techniques that the testing world can actually bring over, right? And so whereas the AI machine learning type of validation and verification can be very much focused on looking at accuracy, precision, recall, a lot of those, while they're very scientific, aren't really representative of the practice of testing and quality assurance. And then what can we bring over from the testing world, from a practical standpoint, that helps with the holistic validation? Because at the end of the day, that machine learning component, that machine learning model, that is going to integrate into a bigger ecosystem. And as Rajni mentioned, what testers bring to the table is that big picture and how things fit all together. And so that's important. And with that comes a level of cross-pollination from the perspective of even career transitions, right? So starting to think about what are the future roles that will maybe exist as a result of this new paradigm being commonplace in organizations, and thinking about testing a little bit differently. Myself, I've gone through my own transition, right? I went from being a local test leader, heading up the quality program at a relatively large organization, which is great. And and impacting their customers, right? But now thinking about where I am today, it's a little bit different, because not only am I just impacting testing and the way that we test, but I'm impacting the way that the world tests software. And with machine learning, you're also now talking about not just impacting testing per se, but the entire development life cycle, all the engineering that goes into all the programming and the data in that space, which is really what true testing is all about. And so it kind of brings it from what traditionally in a waterfall model has been known as testing to really being representative of holistic testing. And now, instead of a local impact to that organization and its customers, it's really more of a global impact on the world, which is pretty exciting. And I've also seen my team go through a transition, right? Thinking about a tester or even an architect in an organization, thinking about their world, which usually revolves around maybe a feature or a set of features, to now looking at the team developing into machine learning engineers and understanding machine learning operations, including machine learning, including development, and including operations, and thinking really about continuous validation and verification throughout that life cycle, and being responsible for delivering AI solutions using this idea of machine learning operations. But when you look at this machine learning operations model, it's not very evident where testing is. And that's because testing is actually everywhere when you start to think about this, right? Because if you start thinking about the experimentation that happens at the beginning of the machine learning process, or the data processing or model training, all of these things are in essence directly related to testing, and actually involve validating inputs and outputs and actual results and expectations, and testing hypotheses, and all of these things that are an integral part of being a tester. So it's everywhere, but at the same time, it can also be nowhere. It really depends on whether or not some superheroes show up to the show. And I'll explain what I'm talking about as we go back to our feature presentation. So hopefully at that point, you understand a lot of the truths around it. And if you recall where we left off in our feature presentation, we were dreaming of this alternate reality where maybe there's better software, and where AI and machine learning are being held back and being contained. And this is really the big picture of that alternate reality. This idea of better software first starts with bad software going belly up, right? And by going belly up, we might actually get our world back. And then what we can start to do, because testers are the ones actually keeping AI and machine learning at bay, AI and machine learning is still driving better software forward. And actually the world is slowly and surely getting filled with better and better software. So testers will have it under control. And those are the superheroes that I'm talking about, where I think in the not so distant future, we can get to a place where there is better software, where we trust the AI and machine learning models. And so you can actually design better software using trusted AI. You can leverage a lot of the software development techniques that now leverage AI to actually implement systems. And a lot of the testing frameworks and the automation and all these things that we talked about are actually being used to validate and verify the system. And even things like security, as was mentioned, we're protecting the system using AI. But we have to get there. And to get there, we need these superheroes. These are the AI and machine learning operations engineers, but they're really represented by our testing superheroes. And so I expect that testing and testers in general will play a critical role in monitoring and maintaining the AI and machine learning systems of the future, which really enable us to build better software. And so with that, it comes to the core theme here, which is that testers are really the key to this AI and machine learning revolution. And, we take this sometimes for granted, what is actually brought to the table, because a lot of the testing role has been undervalued and underappreciated for many years. But testers have a lot of traits that help us to build better software. Our ability to have user empathy, right? Put ourselves in the place of the end user. We also are very good at thinking outside the box and being very creative with our ideas. And let's not forget the human side of all of this, which is that we need to be able to bring, if you're thinking holistically, you're thinking of the big picture, you need to be able to bring all of these different people together to collaborate and make sure that they're communicating to actually help make better software. This doesn't happen without people being involved. And of course, we're naturally curious. We ask the right questions and reveal where things might be broken or where there might be additional risks, which is a core part of testing, is just risk assessment. You saw it in Rajni's presentation, right? Like without assessing that, you could be wasting a lot of time. And we always know that we're gonna run out of time. Timing is a very scarce commodity in our world. And then a lot of the constant learning and analysis that we bring to the table. And this is by no means an exhaustive list. There's many more traits, or critical thinking, or ability to analyze facts and make judgment calls. But these are the skills that I think can help close the quality gap between the AI and machine learning work streams and our traditional work streams, if you want to call them that. And so I encourage you to think about this new breed of testing superheroes that is on the horizon. We saw a talk on security as part of this online recap. And I think, if I think about the tester of the future, one of the roles could be to actually design, build, and train machine learning models, that those models themselves are aimed at supplying deceptive input to another machine learning model or system to make sure that testing can be better. You can improve testing and use that as a feedback loop to make it better. The hackers are out there using this technology. So if we're not using it ourselves to help train these models to become better and stronger, then we're going to be behind the 8 ball with a lot of these things. Or maybe your testing superpower is to deal with fairness and ethics, and whether or not there's groups that can be harmed from this technology, right? Especially underrepresented groups that are already at risk. So maybe that's your superpower. Maybe that's what you're bringing to the table when it comes to AI and machine learning. Or maybe it has to do with culture and making sure that your machine learning systems that are interacting with humans are actually culturally sensitive. And again, a big human aspect of that is the way that we approach these types of problems and understand other humans. And of course, there's just general need for validating the models and looking at things like model performance and so on. So there's definitely a lot of different roles that probably could fit in the future, where we are not necessarily thinking of ourselves as testers only, but that are really using all those skills to help make software better and make AI and machine learning better and make it a success. And so I encourage you to also try to start to train that superhero. A lot of people always ask me, like, how did I break into this field? And I'm always reminded of Dawn Haynes has a saying that she had years ago, that performance testing is rocket science. And I found that to be true of someone who's led performance testing teams. Performance testing is hard. But I decided to coin and say, like, AI is actually not rocket science. I had a harder time learning about performance than I did breaking into AI and machine learning. And so many of the reasons you saw in kind of how things are set up and structured. But I encourage you to build AI and machine learning foundation, and we can talk about this in Q&A. And we certainly built some of that foundation during the workshop at the conference, where you can learn these foundations. There's a lot of material out there. There's a lot of hands-on things that you can start to engage in to build up that foundation. And then choose a superpower, right? I'm always a firm believer in focus, and sometimes just picking something that you're passionate about, whether or not it's security, whether or not it's the culture stuff, whether or not it has to do with cloud or mobile or web or something technological. It doesn't matter. You just make sure that you pick that and you just focus on it, and go hard or go home is what I always tell people, right? Just either you're going to do it all the way or just don't do it at all. Don't have to it, and don't be mediocre about your craft. And then just hone those skills, like hone those skills to the nth power and the nth degree, and keep going. Because I think that there's definitely like a revolution going on. And it's not just the AI and machine learning revolution. It's a revolution in software. It's a revolution in our careers. It's a revolution of the testing space. And I encourage you to join that revolution. But we're not really done yet. It looks like a wrap. But remember, there's this feature presentation, and we talked about this kind of alternate reality and this alternate ending. But there is another reminder, another very stark reminder, very serious reminder, which is that there is another ending that could result, right? It doesn't just have to be that we have testing superheroes and that the world is filled with better software. And people say, oh, well, we don't have to worry about AI, it's not there yet. But the truth is that number one, there's a lot of very smart and talented people in this space of AI and machine learning that are seriously worried about the progression of things. All the tech giants, whether it be Google or Microsoft, or everyone is leading initiative around trusted AI. I just saw Mozilla post something recently. So the idea that AI and machine learning could actually take over and cause a lot of chaos in this world is not a myth by any means. And while we're not at that singularity yet, we're seeing a lot of efforts around building what is narrow intelligence in different areas, and it's happening all over. And if we think about how we develop as human beings, how we learn as children, like we start learning these individual pieces of things and study different subjects in school, and that's what the AI machine learning of today is actually doing. But at some point, you can take all of that knowledge from those different verticals and start to coalesce it. And as human beings, this is what we do, and this is how we become more skilled. And as we grow as adults, we become specialists in things. And so just think of the AI systems of tomorrow as those children who graduate up another level and are now thinking across multiple areas and multiple domains and able to do more across that. And because of the compute power, because of the tremendous fact that machines don't get tired like humans do, and that they can scale, without a lot of costs associated with what it takes to scale humans, that there definitely could be something that takes over. So I encourage you to join the revolution, not only for the upside, but to also prevent some of the downside, and recognize that testers and testing and the association of software testing and the community that is behind that all have a contribution in my mind to make to this space. And with that, we can stop and open up for questions.
Awesome. If you've got a question, feel free to unmute and ask Tariq your question. And if you don't feel comfortable doing that, we can read it from the chat if you'd like to do it that way instead. Or if you have a mic issue, that we can do that too.
I have one question. So this is definitely interesting, but currently there are very limited sources of training and learning available, which are also costly. What would be your recommendation if someone really wants to learn on their own, and typically they don't have budget from the employer for investing in this learning? What would be the resources one could kickstart and start really getting the hands-on experience of AI-based testing?
Sure. And I've done this enough to know that this is the first question that comes every single time. So I could train a machine learning model to predict this question. So a couple of things first. The first thing is that foundation. And that foundation that I mentioned can be built up through a number of ways. Yes, it can cost a lot if you want to do a formal course, no doubt about it. But Andrew Ng has a free course on machine learning foundations that's available on YouTube from his Stanford days. Lex Friedman also has a free course on there from MIT on self-driving cars and autonomous driving. And actually, these are, I'm saying these because these are things that when I started, that's where I started, by theoretically looking at those things. Now, of course, theory is important. It's good to have that conceptual understanding. But your question on the practical side, there's a site that I love to refer people to. It's called machinelearningmastery.com. I can paste it in the chat there. But Jason Brownlee is a PhD. Let me just put it there, machinelearningmastery.com. Jason Brownlee is a PhD that has quite a bit of practical just experience. And, you know, like, again, there's theoretical machine learning and then there's practical machine learning. And he definitely is an advocate for practical machine learning. And so I started there as well. He had like a free email course that you can do. Again, I'm pointing to all the free resources based on your question. Just to know, like, again, I started with these things and I didn't, yes, I have a PhD in computer science, but I had that long before I got into this field. So most of the learning and education I did this way. And so because Jason Brownlee shows you how to use a lot of the libraries in Python and just get started with things like scikit-learn and take the concepts from just that, a concept, into a hands-on thing. And I always recommend people, like, just start building your first classifier, like just start there. Jason Arbor and myself actually have a course that we teach at a lot of the STAR and Better Software type conferences, and same one that I do at the AST at CAS last year. And even though those courses are things that you would pay to attend the conference to, some of the materials and a lot of the materials are actually open and out there. So I can point you to those resources as well. For folks who's maybe they're also plugged into the O'Reilly platform, if your company or organization has access to that, I teach a course on there on quality engineering for AI and machine learning systems. So I've had a lot of people, like, normally on that platform, everything is anonymous. So I've had a lot of people tell me, hey, I took your course on O'Reilly and stuff like that. So, and so, yeah, there's information, there's tutorials. We did a lot of, mostly all the tools, with the exception of like one or two in the at the CAS workshop that I did, were all open tools that are freely available to use.
Are there any offerings from AIST that you had started in the beginning? I'm not sure if it's still functioning.
Yeah, no, yeah, I know what you mean. There's no offerings from the ASTA. Test AI does have a free edition download. So if you go to our download page at test.ai, we have two variants, right? There's a codeless solution that you can get started with for free, personal edition for codeless. And then there's the SDK that integrates with like things like Selenium and Appium. So you'll just, when you go there, actually, it'd be great if you want to just get a hands-on thing. Even though it's a commercial tool, the free edition is kind of fully functioning for a single user, and you can start to see how AI is used to build test automation. So I encourage everyone to go and download that. Again, it's free, and it's not like sign up and sign your life away. It's just go there, download, and get started. We want to make that very easy for folks.
Cool.
And then there's some other offerings that are out there too. The diffblue, if you're looking at unit testing in Java, diffblue.com. So I'll put all these things in the chat. Is also a good free download and a plugin to IntelliJ that you can just get started with. So there's more and more free information and free tools available out there for you to use. So I'll paste those links in the site. Any other questions?
No, that's for now. Thank you.
Anyone else? Curtis, you want to share your horror story? Is it a short story?
I can make it pretty short, I guess. So years ago, I was working for this company called Huge, and we were tasked to make the companion app to an NBA 2K 14, 16 something game where where users would be able to scan their face with the app, and that would show up in the game. And they had already gotten in trouble with previous versions where it didn't work for African Americans, Black people. And so I was added to the project as the tester, and after a couple of weeks, and they told us that they knew we weren't responsible for the AI part. They had a different vendor for that, but just testing the app. And they told us that they knew that it didn't work. It didn't work as well for Black people, and it didn't work very well at all for women. And they were okay with that for some reason. That's something to do with the sharpness of women's features mess with it. But yeah, after a couple of weeks, they pulled me from the project and replaced me with Elizabeth. And she could almost never get the app to get past the face scanning phase, and to even like test the later stages of the app where you're entering your name and uploading and everything. It was a disaster. I actually I got the phone that she was using back from her, and I looked at the photos on it, and she's trying all these weird angles of her, all these weird angles to try and get her face to actually scan into the app. It was awful.
Yeah, I've seen, so there's a study, gendershades.org. I think you can, I can put it there as well. A study actually that was done specifically around there was a lot of like 3 major products that use the facial recognition that all kind of ran into those problems where both Black people as well as women, it was pretty rough. And so I always point people to that as something. I've also seen, I presented at the JAS conference, the Japanese Symposium on Software Testing, back in 2019, and we had a really big discussion there on a panel on facial recognition that was being incorporated into this system for assessing whether or not you were posing right for a passport picture, right, for immigration purposes. And it had not been tested on Asian people. And so the software kept asking them to please open your eyes, please open your eyes. And then there's the chatbots on Twitter that just learn racial slurs. And I mean, like this, when I tell people that we talk about this AI apocalypse and it's, it just seems all dramatized. It's like, no, this is software that's being built and that's being deployed and that's impacting real lives and real people. And if I talk about bad software already being in the world. If we continue on this path, there will be no better software. It'll be infinitely worse software, or at least exponentially worse. And so we need testers to be involved and to bring their diverse backgrounds to the table, to be able to validate these systems holistically for issues, whether it be fairness, like you mentioned, whether it be trust, whether it be ethics and just social implications of AI and machine learning is pretty serious. So yeah, check out Gender Shades. Thanks for pasting that link there, Dwayne. And I sympathize with your horror story but there's more. That's just one in that local company. But
Yeah, I
there's
understand
Amazon.
that it's a common problem. Thankfully, ours
Yeah,
was
yeah.
just a stupid game that
Yeah,
you didn't even really
Amazon
need to
was,
use it
well, that's a
to
pretty
play.
important game, actually.
Well,
that's a pretty important game
but
in my life. But FIFA is more important, I agree. But the NBA 2K
yeah,
series,
it's no FIFA.
Yeah. but yeah, Amazon had to pull back in 2014. They had a resume analyzer that was built with machine learning that was systematically discriminating against women because guess what the training set was? There was a bunch of male mostly white engineers fed to the system. So it was learning that this is the type of person that I get. And if it saw a woman or someone with a different ethnic background, that was a no, right? So
And Apple had the
we got to
credit
think about these
issue.
things. Yeah, and they pulled that whole project right away once they found that. So
Yeah, so I mean,
it's fine.
I think that you bring up good points. Like we as testers need to be really good about trying to find those biases and make sure that we're testing for them, so that we're making sure our companies are protected against discrimination.
For sure.
So Tarek, I wonder, there's a whole other dimension here, which is AI systems that are based on junk science. So, for example, systems that are deciding whether people who are being interviewed for jobs are honest based on either their word choices or on their facial expressions as they speak. You comment on that and where you see a role for us. I mean, I see roles for testers all over the place, and I've been talking about this a lot at conferences. But
yeah,
in many cases, what we're having to do is question the very premise on which these systems are being built. Frankly, there are a lot of systems being built that should not be built.
Agreed, and that comes into having someone with a testing mindset be involved from the very beginning, right? Like from the inception of the project, right? Like, is this actually even something that we should do and that we should build? Will it, like a lot of these problems can actually be halted before they're started, like you said. But you're absolutely right, and this is actually why, like, for kind of like the, I don't know, call to action that I had, it was to get us to start thinking about roles a bit differently. Like the role that we would fit in, like this is the skill set that we bring to the organization, and you want that to be something that's threaded from the inception, and especially up front in making these kind of decisions and being advisors to technologists or even companies that are making these decisions of where to go with AI. If you don't have someone with this kind of mindset on your team in that meeting, you're going to put maybe millions of dollars into a project that should never have started in the first place. So I agree with you 1,000%. Do I have a solution for getting companies to start to realize this from early? Not yet. My kind of decision or path for starting is to start to move the testing community to recognize that they are needed in this, call it a battle, but in this future. And so I'll start there. And then as I, brick by brick, company by company, run into folks, I do kind of mention like, hey, how's your company approaching this? Like, are you involving people with this kind of skill set on your teams? And we need those people, not just in organizations and stuff like that, but we talk about trusted AI and we talk about all these maybe standards that might be put in place and stuff for engineering trusted AI. We need testers and folks like that on those committees driving those discussions, from the get-go, right? Not waiting until afterwards to be involved. So great point. I don't have a great solution, but I encourage you to continue doing what you're doing and motivating folks along the way to do the same.
One of the things that I think that I would like testers to start looking at is the kinds of systems that we work on. I heard somebody, great guy, recently being interviewed about ethics, and he said at one point, I don't work on life and death systems. I could never do that. Well, maybe we should.
Yeah, we should.
Maybe we should be making sure that we work on important stuff.
Yeah, for sure. That's probably where we should start first, actually. So,
anyway, thank you.
Thank you.
Well, awesome. I appreciate both of our presenters for coming today. So a big thank you to them. And thank all the members for showing up and joining us today. I'm glad that you're able to join. I'll be doing some more surveys to see if we can either change the timing potentially or just figure out a better way to get some more members engaged with some of these great presentations that are happening. So again, thank you to everyone, and we will hopefully see you all at CAST for CAST 2022. And if you need any more information, feel free to reach out to us over Slack or email, or even Twitter if you needed to that way. And we will work on also getting a recording available to members for viewing.